Hi guys, did you ever think that you would be able to make something like this, or even something like this, or even something as tiny as this little chess piece here from one machine? This is what we're going to call the future of manufacturing. So my name is Mehul Shah and I run a company called Ultra-Red Technologies Limited. We primarily are a 3D printing house, and we design products and we print pretty much anything you can imagine, from toys to prototype bottles, packaging, to prototype plastic products, dental equipment, engineering products, to miniature buildings even. And for those aspiring architects out there, we can actually print your entire house and take it apart inside, and you can play around with your house way before you even build it in reality. And all this is possible today. And just because we can, we even printed our own table legs right here. So yeah, let me take you through the whole process. So everything starts on the computer, right? So right here we've got to create all the designs, and this is where the magic happens. So we first have to think about what we want to do, design it, and then once the design is all set, we set about printing it, right? Now to print a design, first you've got to create everything in 3D online. Nowadays in the world there are so many ways to do that. There's a whole repository of files you can find online for 3D printing. And once we have a ready design, we can take it into something we call a slicer, right? So what a slicer does is it translates what I've been designing in 3D into something that the machine can understand. And from here what happens is that it deciphers your 3D design, takes it into steps, and from here I put it onto an SD card, so something like this. And that's what we put into the machine straight away. With me, let me show you how we load up the machines. So now what we'll do is, we set up the machine by placing our SD card into the machine, and then we set up the print right here on the computer screen. It's that easy. And once I set the print, it could take anything from, the longest print we've done ever is 105 hours in one go, and the shortest is about 6 minutes. So, it literally is anything that you want, and that's how it works out. So right now the machines are all working on different items. So right here we have something that is an electronics enclosure for a smart water meter. And the advantage we've got here is that we can create a new design for every different kind of product. There is no need for a mold. There's no need to order like 1,000 pieces. A new inventor can actually come to us and say, I want to test out my design with you, I want a few samples here or there. So this is one that's a water meter. Here we've got something for a client. It's a separator for agriculture. Here we've got something in the furniture industry. So we are creating a kitchen box. And here again we've got the smart water meters. So you see, all with the same machine, we're working throughout different industries and using different types of materials. And I'll be like, I think something has just finished on our big machine. This machine is called Big Daddy. So this is a very interesting part. This is a nose cone from a propeller on a civilian aircraft, right? And this is actually usable from the machine, straight out from the machine. The pilot can take it, put it on. And these kind of parts are quite hard to find nowadays. So the best way to do it is by 3D printing. We can create our own designs, we can customize the design, and you can pretty much make anything. So restoring old aircraft, restoring old cars, and the advantage we have here is the materials that we can use. Right? So here at Ultra-Red we've used about 15 different types of plastic, all depending on what the application is. So this is an outdoor-based PET material. PET is what people normally use for water bottles. And here we are using it for aircrafts. So there's multi-uses in everything. So once the print is done, we just have to take a small scraper, get under, and just pop it off. And it comes off and now I have a finished product. So this is ready to go on the airplane. So we can actually print anything up to 1 meter tall on this machine, right? And we've printed things that are bigger. So what happens when you're printing bigger items is you cut it into multiple pieces, and then we put everything together. But yeah, with this machine, it's 1 meter tall, so you're looking at something that's about there, and we printed that in one go. So we've printed life-size items that are used, like, for example, toilets, new types of toilet designs. We've printed the entire thing, so if someone can actually pick it up and use it and test it before they ever make the product, right? And it's very easy to take a computer design and print it. So you could actually, nowadays you could actually scan a person, so I could scan myself and print a copy of myself. So in terms of plastic materials that we have to print with, we have, like I said, between 10 to 15 different types. And this, for example, is a PET kind of plastic, which is a very common plastic you find in every household, especially in your drinking water bottles. But obviously the color will be slightly different, and the properties when you're 3D printing are slightly different from when we use other forms of plastic manufacturing, right? And here we've got a PET also. So this is more similar to your drinking water bottle, with a clear material. Here we have something called PLA. It's a polylactic acid. So this is a very special kind of plastic. Usually plastics are made from oil. This plastic is actually made from cornstarch, from maize. And this is a biodegradable material, in essence. The majority of 3D printing items use PLA, polylactic acid. Here we've got something called ASA. ASA and ABS, as it's normally known, are very hard-wearing outdoor materials. And we can use these for printing stuff for the vehicles, stuff you want to put outside, plants, pots, and it's very hard-wearing, very tough, and yeah, that's that. Here we've also got a different kind. This is another form of PET. This is PET with a modified glycol, just to make it easier to print with. So in terms of other stuff we've used for industrial and engineering stuff, we use nylon. So nylon is a very, very tough material. You can print gears, you can print spare parts for machines. So we've actually used that. We have carbon fiber as well. So carbon fiber is one of the strongest materials that you can find in terms of plastics. So we've printed with carbon fiber, we've printed with glass fiber, and eventually we hope to be printing with metal very soon. So in terms of color, what happens is that whatever color we feed into the machine is what ends up being there. So you can have a very wide variety of colors. So here we've got a sample shade card of what colors that we can offer in terms of printing. But the possibility is open for you to print any color that you would like. So when you're printing, what happens is there's sometimes print failures and something called support material. So the way printing process works is you need support material to build up. It's like scaffolding in a building, right? Now, unfortunately, we can't reuse that in this process. But what we do is we collect all of that. And there's a project called Plastiki Rafiki from ISK school. And these kids, what they do is they take the plastic, they grind it up, and they melt it, and they turn it into new products. Like keychain holders and all sorts of different things, even jewelry. And that's all comes from the waste of this. So technically we're recycling pretty much everything that we use here. And there is also recycled material available to print with. For example, here we're using recycled material. And all of our material comes from Spain at the moment. So primarily the material comes from Spain, and there's a little bit that comes from China, and it depends on which process that we're using. But I would say 90%. 3D printing is something I was really excited about growing up. So I studied engineering in university, and I was fortunate enough to go abroad to Bristol University in the UK, and we had let's say about 10 3D printers that we could use as engineering students. So I used to tinker around a lot with those machines, and I learned a lot about the whole 3D process, from designing to printing to making stuff. And you know, even if you roll back the years, I was fascinated by Lego growing up. I used to play a lot of Lego, used to build things with Lego. So as soon as I could start building my own things using these machines, you know, the idea was like, yeah, I need to do this. I really need to get into this. I started Ultra Red Technologies in 2014. So what happened was that I was developing products. So I was actually working on something called a solar concentrator at the time. So, you know, solar heating is a big topic because it's saving fossil fuels. So me and a colleague, a friend of mine who we studied in school together, he also moved back to Kenya from the UK. We started this company to develop something called a solar concentrator. Now, as we were doing it, we had to create so many products ourselves, and we didn't have access to 3D printing at the time. So we really had to figure out how to manually create everything, and from there we became masters at product design. And naturally, when you do product design, you need something, a tool that'll really help you show what you're going to be making and what you're going to be designing. And that's where, you know, we decided to look for this as a technology that's really going to enhance how we work. Unfortunately, we didn't go ahead with the solar concentrators because we could never find how to commercialize it. But people started taking notice of our ability to design products. So one of the first companies that we worked with was Coco Networks. And, you know, they're a big success here in Kenya, and they provide ethanol stoves, gas cookers for home use, and they have a whole ethanol network. So it's clean fuel cooking. So we were happy to be a part of that team to develop the actual stove. So that entire product development happened here in-house, and that really showed us what's possible in Kenya in terms of developing a product. And since then, we've been working with plastic manufacturers, with lots of innovators and inventors, entrepreneurs who want to start off something small. You know, we're an ideal house for them to come to, and you know, we can grow with them, and that's how it's been working. We've got quite a few risks of doing this kind of a business in Kenya. So in terms of technical abilities and what's being taught in our curriculums and around the world, this is all cutting edge stuff. You know, what we're doing is at the forefront of manufacturing in the world, not just in Africa and not just in Kenya. So I mean, this technology is new everywhere in the world. So the challenge for us is actually upskilling and training people. And growing our team, and so what we've done to counter that is we've started developing our own in-house training, and we want to train people to be able to design, to democratize the whole design process, and lift it in a way that, you know, as Kenyans, Jua Kali is part of our blood. You know, we've been doing this for many years, where people make stuff, and now we're basically trying to make it easier for them to do that. The ideas are there. I just need to train people. How do we bring them to a platform like this, where hands-free, I'm running a little factory without even, you know, having to manually work on it. So it's all automated. And this really opens up the possibility for us to make all our own products and not have to rely on importation. So that, that's one of the risks. The other risks, obviously, our infrastructure is not the best. So we get a lot of power cuts and power failures. Now, with 3D printing in particular, any sort of power fluctuation and you lose whatever you're printing. So just imagine I was printing something that's 100 hours long, and at the 90-hour mark, the power goes, I lose everything that that was printing for 90 hours at that time. So we've had to invest a lot in power backup systems, just to ensure that these machines are continuously running. And I guess the other risk that we have taken is that we've ventured into something very new. Not many people understand the potential of what 3D printing can offer. So I find that I spend a lot of time educating our clients. We got to spend a lot of time with them and really make them understand what's possible. And also we have to understand from their point of view what their needs are. So to convert a sale, it takes quite a long time. And obviously the risk in that is that the longer we spend trying to sell something and not selling something, we run the risk of losing a lot of business. Yeah, so if we set up a very strong, solid foundation and a really good idea of how people can innovate and how 3D printing can help, we can really expand our market. So yeah, this was an interesting challenge. So when you have the ability to make anything, your pricing strategy has to be that flexible. So today we could make something this small, or tomorrow we can make something 2 meters big. So the way our pricing works, it's all an algorithm that we calculated based on how long it takes to produce the item and how much material that we're going to use. So it's actually very transparent. We walk our clients through, this is how the process works, yeah, that's pretty much how we price it. So you can have something that's like something as small as 50 shillings, or something that can be 500,000 shillings. So the range is massive, and all depends on what the client's needs are, how big the product is, how long it's going to take, what material is going to be used. So there are quite a few factors. Yeah, and then there is a kind of fee for designing as well. So if someone has an idea but they haven't done the 3D design, we can design it for them at a small fee, and you can turn some paper sketches into something in 3D in a matter of a few hours, put it on the machine, print it. The next day the client has the item that they envisioned. Yeah. So we've been primarily focusing in the Kenyan market. We've done a couple of sales outside in the East African region, Tanzania, Uganda, Rwanda, and a few prints have actually gone overseas to Germany and to the US. But the way 3D printing works is it's so democratized that we can just send the digital files and someone in Germany will print, or someone in the UK can print. And all we do is we set up the proprietary information. I'll give you an example. When we went into lockdown, when COVID started, it was about March 2020. We created some files for a face guard, right? And the maker community was really big at the time, and people were designing stuff, sharing our designs all over the world. So we optimized one of the designs and put our input and gave our tips of how to produce this the best way. And we made those files open source online, and people all over the world were using it. So in essence, that we've managed to reach everyone around the world with simple digital design that they can print from any printer in the world. This is all plastic. What we are capable of printing here is all plastic. If we look globally at what's happening in the 3D printing space, people are printing in metal. So a lot of the parts that are used in the space shuttles and in space exploration is 3D printed titanium and 3D printed aluminum titanium composites. You know, very high advanced materials, and it's all with 3D printing. In Dubai, there was a housing complex and an office block that was 3D printed. In construction, you know, that's going to start happening. There's a project going on through Bamburi Cement here in Kenya. They're going to be 3D printing homes. And so you're looking at, you know, spare parts, machines, cars, what you live in your house, even bridges. Like, for example, in the Netherlands, there's an actual robot that has 3D printed a bridge, and it's also designed it itself. So it's used AI to design, and it's used 3D printing to manufacture without the need for a human to input, you know, how the bridge should look. The computer's actually taken over completely. So this is how the future of manufacturing is going to go, and we want to bring it to Kenya at the same pace as the rest of the world. So I really want to educate the wider market in Kenya and really open their eyes to let's see how we can make things better. You know, we rely so much on importation here. We want to really shift that mindset, and I think a stretch goal for UltraRed is to really change the landscape of manufacturing here. And me personally, I really want people to embrace this technology, embrace the ability to design, to make. You know, kids nowadays, they shy away from subjects like maths and physics and engineering. We want them to be excited about it again. You know, we want kids to pick up these printers, print their own toys, print things that they want for home. You know, they need a new phone case, design it, print it. You know, you have the freedom to do that. So I really want to empower and educate people to be able to think of 3D printing as the primary tool that they're going to use to manufacture. So we are a team of 3 founders of UltraRed Technologies, and we've actually financed the whole business ourselves. So we started small, started with, you know, a small machine, and as the company has grown, we've actually grown organically. We haven't got any investors yet, but that's something that's going to be on the pipeline. If we really want to grow and impact the way we work here, we will be looking for investment very soon. So tips I can give to people who want to get into 3D printing. There is a learning curve, yeah? So don't be intimidated the first time. It's not something that you can just press print and it'll happen. You've got to learn a lot. There's a lot of technical nuance that goes into these machines. So you almost have to be ready to be an engineer, to be a mechanic for your own machine. But once you do that, the rewards are amazing. I would say really learn how to design. The machines, they work very nicely, but it's about what you feed them, right? And if you don't design good products, you will not make good products. So learn how to design, and nowadays in the world you can go on YouTube and learn all these things for free. All it takes is a bit of willpower and effort on your part, but you will learn how to do it very quickly. And third, it's not expensive. You know, you can pick up these machines for quite cheap. So we actually supply machines here in Kenya. So if kids or students or anyone wants to try 3D printing, they can come, they can talk to us. We will educate, we will train, we will help them all the way through the process. So yeah, don't be scared. It's not some out there futuristic technology. It's here and it's ready to be used.